In this class, we study major power quality problems. So, what are the major power quality problems? That is transients, short duration voltage variations, long duration voltage variations, voltage imbalance, waveform distortion, and voltage flicker. So, in this class, we study only 4 of this one. That is transients. Transients, we are having two types: impulsive transients and oscillatory transients. And this transients is a sudden increase in the voltage spikes. That is of impulsive. Impulsive means sudden and short impulse in your voltage waveform. So this transient, the main causes of this impulsive transient is the lightning and electrostatic discharge. And oscillatory transients, it is followed by the impulsive transients. And next one is a short duration voltage variations. Short duration voltage variations is the voltage variations in 1 minute, within 1 minute, that we call as short duration. And there are of 3 types, that is short duration interruptions, you just see that short duration interruption, next one voltage sag, and third one voltage swell. Short duration voltage interruption may list of 3 types. There are momentary, temporary, and like that, and there are of 3 types. So short duration interruption closed in the voltage for a very short durations. Next one, voltage sag. Voltage sag is the decrease in the voltage, that is amplitude of voltage, for 0.8 to 0.0 pu per unit of your normal voltage. അതായത് വോൾട്ടേജിൻ്റെ നോർമൽ വോൾട്ടേജ് അപ്പോൾ ഒരു 230 വോൾട്ടേജ് കൊടുത്തിട്ടുണ്ടാവും. ആ 230 വോൾട്ടേജിന് കാട്ടി ഒരു 180 160 വോൾട്ടേജ് ആ റേഞ്ചിൽ നമ്മൾ വോൾട്ടേജ് നമ്മൾ വീട്ടിൽ കിട്ടുവാണെങ്കിൽ അത് നമ്മൾ വോൾട്ടേജ് സാഗ് എന്ന് പറയും. നെക്സ്റ്റ് വൺ we call voltage swell. Voltage swell is an increase in the voltage for a short duration above 1 pu. 1 pu is the per unit corresponding to a 230 volt. That is the standard volt. So above that one, that is 240, 250, 260 volt for a very short duration is called as voltage swell. So these are all of short duration voltages. And long duration voltage variation is of under voltage, over voltage, and this will comes under long duration voltage variations. Okay, now we see in detail about the transients. Transients have a magnitude of several thousand volts and so can cause damage to the installation and equipments connected to it. They have a magnitude of several thousand volts and can cause damage to the installation and equipments connected to it. Transients can be classified into 2 categories, that is impulsive transients and oscillatory transients. So you can see this impulsive transient voltage spikes. So impulsive transients are of positive, there are of not negative types. It is only of one side transients. So we see it is a sudden non-power frequency change in both steady state condition of voltage, current, or both. That is it is a sudden non-power frequency change in the steady state condition of voltage and current. It is unidirectional in polarity, primarily either positive or negative. ഒരു either പോസിറ്റീവ് ആയിരിക്കും ഇല്ലെങ്കിൽ നെഗറ്റീവ് ആയിരിക്കും. മോസ്റ്റ് ഫ്രീക്വൻ്റ്ലി ഇറ്റ് ഈസ് പോസിറ്റീവ്. ഒരു യൂണി ഡയറക്ഷണലാണ് ഈ എന്താ പറയുക ഇമ്പൾസീവ് ട്രാൻസിയൻസ് ഉണ്ടാവുക. സോ വേറൊരു കാര്യം, ഇമ്പൾസീവ് ട്രാൻസിയൻസ് ആർ നോർമലി ക്യാരക്ടറൈസ്ഡ് ബൈ ദർ റൈസ് ആൻഡ് ഡീകേ, which can also be revealed by their spectral content. They normally rise from 0 to its peak value and then decay to half of its peak value. And you just note down one more definition which I am not able to include in this slide, that is IEEE definition is of an impulsive transient is impulsive transient is a non-power frequency change in steady state condition of voltage, current, or both, that is unidirectional in polarity, either primarily positive or negative. It is normally a single, very high impulse like lightning. So you can see that the most common cause of impulsive transient is lightning. So lightning is the major causes of impulsive transient. So that you can see here, that is a voltage spike here, that voltage spike which we can see here, voltage spike which comes here, and then it is returned to the normal condition. So that we can call as impulsive transients in lightning. So the major causes, as mentioned, lightning is an example of an impulsive transient. Current produced from the lightning strikes can go as high to several thousand amps. So you can see several thousand amps. So next causes is the electrostatic discharge. So electrostatic, what do you mean by electrostatic discharge? Electrostatic, you can see, is a form of impulsive transient exhibited by rapid and momentary flow of electrostatic charge. So rapid aito or momentary aito or electrostatic charge flow ചെയ്യുന്ന നമുക്ക് എന്താ പറയുക, ഇലക്ട്രോസ്റ്റാറ്റിക് ഡിസ്ചാർജ് എന്ന് പറയാം. So this electrostatic discharge may not harm an human, but it will harm the electronic equipments majorly. So what are the causes of impulsive transients? What are the causes? That is transients and electrostatic discharge. These are all the two causes. So next one we see about oscillatory transients. It is a first we have seen the impulsive transients, and next we see the oscillatory transients. So it is a sudden non-power frequency change in steady state condition of voltage, current, or both. It includes both positive and negative polarity values. So in impulsive transients, it includes only what? It includes only either positive or negative. So here the oscillator transients, it includes both positive and negative polarity values. It consists of voltage or current whose instantaneous value changes polarity rapidly. It consists of voltage or current whose instantaneous value changes polarity rapidly. It is described by its spectral content, that is predominant frequency, duration, and magnitude. Based on the spectral content, oscillatory transients are classified as high frequency, medium frequency, and low frequency. So we can see that this one is the oscillatory transient. Oscillatory transient means ഒരു ഇമ്പൾസീവ് ട്രാൻസിയൻ്റ് ഉണ്ടായിട്ട് ആ ഇമ്പൾസീവ് ട്രാൻസിയൻ്റ് ഡീക്കേ ആകാൻ നോക്കും. ഡീക്കേ അത് ഇവിടെ ആ ഒരു പർട്ടിക്കുലർ പോസിറ്റീവിലോ നെഗറ്റീവ് സൈക്കിളോ ഒരു ഇമ്പൾസീവ് ട്രാൻസിയൻ്റ് വന്ന ശേഷം അത് ഡീക്കേ ആവാൻ നോക്കും. അപ്പോൾ അത് that is the main causes, that is impulsive transients. After it is an after effect of impulsive transient which we can see. So it will just oscillate on a particular time period. So we can see here it is just oscillating, and it will just decay and it returns to the normal stage. Okay, so you can also see here it is an oscillator. That sudden spike is there, then it causes the oscillatory transients. Then after for a particular time it is being there, then it will return to its normal duration. So that we can call as oscillatory transients. Oscillatory transient, the main effect is the back-to-back capacitor energization, that is ferro resonance, and transformer energization. that is back to back capacitor energization, ferro resonance and transformer energization. These two causes are the main causes of the oscillatory transients. So in the oscillator transient, the transient with primary frequency component less than 5 kilohertz and a duration from 0.3 to 50 milliseconds is considered as low frequency transients. So you can see a low frequency oscillatory transients. So it is of 5 kilohertz and a duration of 0.3 to 50 millisecond is considered as low frequency transient. This category of phenomena is frequently encountered on utility sub-transmission and distribution system and is caused by many types of events. It is caused by many types of events, and the most frequent is the capacitor bank energization. So you can see back-to-back energization is the main causes, which typically results in oscillatory voltage transients with a primary frequency between 300 to 900 Hz. So we can see a frequency, oscillatory frequency between 300 to 900 Hz. Oscillations may cause with back-to-back capacitor energization. The peak magnitude can approach 2 per unit. That is 2 per unit means if it is having 230 voltage, then the peak may approach up to 460 voltage. And the duration of that oscillation can last up to 0.5 to 3 cycles depending on the system damping. So you can see here this duration lasts up to half of the cycle, 1 cycle. So you can see here this duration lasts up to 1 cycle. Okay, so similarly, and you can see this one, this is the 1 per unit, and you can see this one is 1.5 per unit above, and it maximum it can go up to 2 per unit, and then the duration can last up to 0.5 to what I told you 3 cycles, that is 1 cycle, 2 cycle, 3 cycle. So this much duration these oscillatory transients can last. I think you got this, what is meant by oscillatory transients. The causes are back-to-back capacitor energization, ferro resonance, transformer energization. Okay, next we see short duration voltage variations. They are caused by fault conditions such as energization of large loads which require high starting current or intermediate loose connection in power wiring. That is the most easy example is the switching on of your high HP induction motor in your home. That is switching on of your water pumping motor in your home. That causes an slight voltage variations in the bulbs. Incandescent bulb, there you can note down, you can easily note a small voltage variation, that is the voltage may dim or voltage for a very short duration of 1 minute, within less than 1 minute, that we call as the short duration voltage variations. That is short duration voltage variations will not last for an 1 minute. 1 minute നെക്കാട്ടിൽ കൂടുതൽ ലാസ്റ്റ് ചെയ്യാത്ത ഒരു വോൾട്ടേജ് വേരിയേഷൻസ് നമ്മൾ എന്താ പറയുക, ഷോർട്ട് ഡ്യൂറേഷൻ വോൾട്ടേജ് വേരിയേഷൻസ്. Depending upon the system conditions and fault conditions can cause either temporary voltage drop, sag, temporary voltage rise, swell, or a complete loss of voltage interruption. Temporary voltage drop I told you in the starting, that is within 0.8 to 0.5 per unit. So per unit പറയുമ്പോൾ നിങ്ങൾ ശ്രദ്ധിക്കണം, per unit is the voltage, that is normal standard voltage. 230 voltage ആണെങ്കിൽ 230 voltage 1 pu എന്ന് എടുക്കും. അപ്പോൾ 1 pu കുറയുവാണെങ്കിൽ അത് ആ വോൾട്ടേജിൻ്റെ മാഗ്നിറ്റ്യൂഡ് കുറവാണെങ്കിൽ അത് വോൾട്ടേജ് സാഗ് എന്ന് പറയും. 1 pu കൂടുക, അത് 1.1 എബോവ് ആണെങ്കിൽ അത് വോൾട്ടേജ് സ്വെൽ എന്ന് പറയും. പിന്നെ ഈ വോൾട്ടേജ് സൈക്കിൾസിന് ഇടയ്ക്ക് വരുന്ന ഇൻട്രപ്ഷൻ, അത് ദാറ്റ് വി കോൾ ആസ് ഷോർട്ട് ഡ്യൂറേഷൻ ഇൻട്രപ്ഷൻ. ഓക്കെ, I think you got this one. Next we see short duration voltage variations are of three types: short duration interruption, voltage sag, voltage swell. So first one, interruption is defined. First one we see short duration interruption. Interruption is defined as the decrease in the voltage supply to less than 10% of nominal for up to 1 minute. For up to 1 minute duration. They are the result of power system failure, control malfunctions. They are further divided into instantaneous, momentary and temporary. So instantaneous we can see 0.5 to 30 cycles. It lasts up to 0.5 to 30 cycles. And you can see next one, momentary. It lasts for 30 cycles to 3 seconds. That is normally what we can see. If the 3 seconds means that is 50 hertz. 1 seconds, it is 1 cycle. It consists of 0.02 seconds. 0.02 seconds. And in 30 seconds you can have this 30 by 0.02. This much of voltage, this much of cycles which you can expect. So you can have the interruption in your voltage supply. That is, they are further divided into instantaneous, that is 0.5 to 30 cycles, and momentary, that is 30 cycles to 3 seconds. 3 seconds means 3 by 0.02, that is 150 cycles. That is 30 cycles to 150 cycles. And the temporary, that is 150 cycles to 3000 cycles, that is 1 minute. So next one, short duration, we can see that, you can see it is of only 1 cycles. Short duration, this we see about the instantaneous short duration. It is of half cycles to 30 cycles. Half cycles to 30 cycles, say that you can see only half cycle is being interrupted. So this we can call a short interruption. And the normal voltage, it can fall up to 10% of the normal, or it can be interrupted for a particular cycle. Next one, that is, I think you got that, short interruption. Interruption means the failure of the current. Current is being interrupted, that is, current is not being the voltage or current is not being received in a particular house for a 1 minute. ഒരു മിനിറ്റിലേക്ക് ഒരു വീട്ടിൽ കറണ്ട് ഉണ്ടാവാതിരിക്കുന്ന ഒരവസ്ഥയാണ് നമുക്ക് പറഞ്ഞാൽ ഷോർട്ട് ഡ്യൂറേഷൻ ഇൻറ്ററപ്ഷൻ എന്ന് പറയാം. അത് 1 മിനിറ്റ് പറയാം. സോ ഇറ്റ് ക്യാൻ ബി ഇൻസ്റ്റൻറ്റേനിയസ്, മൊമെൻ്ററി ഓർ ടെമ്പററി. ടെമ്പററി ആണ് ഏറ്റവും കൂടുതൽ, മൊമെൻ്ററി മിഡിലാണ്, ഇൻസ്റ്റൻറ്റേനിയസ് പെട്ടെന്ന് ഉണ്ടാവുന്നതാണ്. So next one we see sag. Sag is the voltage dip. A sag is a decrease to between 0.1 to 0.92 per unit in RMS voltage or current at the power frequency for durations from 0.5 cycles to 1 minute. A sag is a decrease to between 0.1 to 0.92 per unit in RMS voltage or current at a power frequency for a duration from 0.5 cycles to 1 minute or 0.5 cycles to 1 minute വരെ ഒരു പർട്ടിക്കുലർ വോൾട്ടേജിന് ഡിക്രീസ് ഉണ്ടാവുന്നതാണ് വോൾട്ടേജ് സാഗ് എന്ന് പറയാം. സോ വാട്ട് ആർ ദി കോസസ് ഓഫ് വോൾട്ടേജ് സാഗ്സ് അസോസിയേറ്റഡ് വിത്ത് സിസ്റ്റം ഫാൾട്ട്സ്. നെക്സ്റ്റ് വൺ, it is associated with the energization of heavy loads, and it is also with the starting of large motors. Sag you can see these are all the three causes. That is, if any small system faults occurs, then also a voltage sag will comes in. And next one, the energization of heavy loads, means a small loads in your sudden operation of your induction motor in your home. It may also cause the voltage sag. And next one, starting of large motors in the industries may also cause a small dip in voltage. And next one, the sag durations are subdivided here into three categories, such as instantaneous, momentary and temporary. So idilum instantaneous, momentary and temporary inde short interruption pole thanne idilum same aanu. So next one, you can see the voltage sag. So voltage sag, as I earlier told you, it is of 0.1 to 0.92 per unit, decrease between 0.1 to 0.9 per unit. So you can see it is the decrease voltage. Normally 1 per unit voltage, then it starts decreasing here, and you can see this is almost 9 per unit, 0.9 per unit voltage decrease. Then after a particular, and you can see it is of three types: instantaneous, momentary and what, temporary. So you can see first cycle, one cycle completed, one upper and lower cycle completed here, 1 2 3 4. ഫൈൻ. ഒരു സൈക്കിളായി ഇവിടെ നിന്ന് ഇവിടം വരെ വന്ന് കഴിഞ്ഞാൽ ഒരു സൈക്കിളായി, 2 3 4 and this one. So 4 cycles. So 4 cycles means 0.3 to 36. It is an instantaneous type of voltage swell. Next, it is an instantaneous type of voltage sag. Okay, next one we see about voltage swell. Voltage swell, a swell is defined as an increase to between 1.1 to 1.8 per unit in RMS voltage or current at the power frequency for a short duration from 0.5 cycles to 1 minute. So here we can say that the voltage swag is for a duration of 0.5 cycles to 1 minute. They are already told, and it is an increase in voltage to 1.1 to 1.8 per unit from 0.5 cycles to 1 minute. 0.5 cycles തൊട്ട് 1 minute വരെ ഡ്യൂറേഷനിൽ ഉണ്ടാവുന്ന 1.1 to 1.8 per unit. What is 1.8 per unit? It is 1.8 multiplied by the actual the actual magnitude of the voltage. So it is, so if you are having the standard magnitude of voltage is 230, then 230 multiplied by 1.8, that will give you the increase in your voltage magnitude in the voltage swell. And voltage swells are characterized by their magnitude and duration. So duration, I told you, it is 0.5 cycles to 1 minute. Causes of voltage swell. Causes means associated with system faults, energization of large capacitor bank, switching of large loads. So associated with system faults, so it will be largely associated with system faults, the energization of capacitor banks and switching of large loads. So you can see here the voltage swell is associated with the switching of capacitor banks, and voltage sag is associated with the heavy loads and motors. Why it is so? Means voltage sag is a dip in voltage. So dip in the voltage is mainly contributed by the inductive load. Fine. The voltage swell is the increase in the voltage. So increase in the low voltage is mainly contributed by the capacitor banks. So that is why so like this you can easily remember these causes. Next one, the severity of a voltage swell during a fault condition is a function of fault location, system impedance and grounding. So based upon this one, these three conditions, the severity of the voltage swell will vary. That is system impedance, grounding, fault location, at where the fault is located. If it is located nearby the load, then it is more severe. Then if the system impedance is very lesser, then also it is more severe. And if the grounding is not being done properly, then also it is more severe. So you can see the voltage swell in this diagram. You can see that this one 1.1 to 1.8, it is almost lesser than 1.5, but you can see it is increasing above 1 per unit. Then it is going. So you can see that 1, 2, 3, 4, 5, 6, 7, 8. So you can see it is about 0.05 to 0.15 seconds. So it is almost 0.10 seconds the voltage swell is being sustained. Has told you that 0.5 seconds to 1 minute. So this is of voltage swell. So next one we see long duration variations. A long duration variation. A voltage variation is said to be a long duration when nominal values of voltage varies for a duration greater than 1 minute. So when a normal voltage varies greater than 1 minute, then it is called as long duration voltage variation. They can be subclassified as under voltage, over voltage and sustained interruption. They can be subclassified as under voltage, over voltage and sustained interruption. So under voltage, it is the decrease in the RMS voltage less than 90% at power frequency for a duration greater than 1 minute. It is a under voltage. It is a decrease in the RMS voltage lesser than 90% at a power frequency for a duration greater than 1 minute. That is 90% of voltage it is a decrease in the RMS voltage less than 90%. Less than 90% means it is not greater than 90%. So we can 230 in the 90% say not taken as 230, 200 you can say 200 and 10% to that is 20, that is 230 if you are taking 23 volt. So it is almost coming around 213 volt, 217 volt to 230 വോൾട്ടിൻ്റെ ഉള്ളിലുള്ള ആ വോൾട്ടേജ് വേരിയേഷൻസിനാണ് നമുക്കെന്താ പറയുക അണ്ടർ വോൾട്ടേജ്. ആൻഡ് ഫോർ എ ഡ്യൂറേഷൻ ഗ്രേറ്റർ ദാൻ 1 മിനിറ്റ്, 1 മിനിറ്റിനെക്കാട്ടിൽ കൂടുതൽ സമയം ഈ ഒരു വോൾട്ടേജ്, അതായത് 217 to 230 വോൾട്ടേജ് സസ്റ്റെയിൻ ചെയ്ത് കഴിഞ്ഞാൽ നമുക്കെന്താ പറയുക അണ്ടർ വോൾട്ടേജ് എന്ന് പറയാം. So this main causes is the overload circuits can result in under voltages. Overloaded circuits. The next one, the term brownout is often used to describe sustained periods of under voltage as the specific utility dispatched to reduce power demand. So it is the term it is being described so that to reduce the power demand, dispatch of the power demand. So over voltage, it is the increase in the RMS AC voltage greater than 110% at the power frequency for a duration longer than 1 minute. That is 230 ൻ്റെ ആണ് എടുക്കുകയാണെങ്കിൽ 23, that is 246 നെക്കാട്ടും 246 വരെ മാക്സിമം ആ ഒരു 230 to 246 വോൾട്ടേജിന് വരെ ഇൻക്രീസ് ചെയ്യുന്ന വോൾട്ടേജ് അത് 1 മിനിറ്റിനെക്കാട്ടും കൂടുതൽ സസ്റ്റെയിൻ ചെയ്യുകയാണെങ്കിൽ ഇത് ഓവർ വോൾട്ടേജ് എന്ന് പറയും. ഓവർ വോൾട്ടേജ് ഇസ് യൂഷ്വലി റിസൾട്ട്സ് ഓഫ് ലോഡ് സ്വിച്ചിങ്, ഇൻകറക്റ്റ് ടാപ്പ് സെറ്റിങ്സ് ഇൻ ദി ട്രാൻസ്ഫോമേഴ്സിൽ ഇൻകറക്റ്റായിട്ട് ടാപ്പ് സെറ്റിങ്സ് ഒക്കെ ചെയ്യുക, പിന്നെ ലോഡ് സ്വിച്ചിങ്സ് ഒക്കെ ചെയ്യുക. സോ എന്താണ് ട്രാൻസ്ഫോമർ ടാപ്പ് സ്വിച്ചിങ്? സോ ട്രാൻസ്ഫോമേഴ്സ് ആർ there in the distribution transformers, they are of step down transformers. On the basis of the stepping down, then we can step down from 1 kV to 440 voltage. So if you are not able to tap set that, if you set it for 460 volt and all, then this extra 20 voltage will be distributed on your entire phases. Okay. The next one is the sustained interruption. When the supply voltage has been zero for a period of time in excess of 1 minute, then we call as sustained interruption. They are called sustained interruption. They are often permanent and require human intervention to repair the system for restoration. Sustained interruption means you can see when an heavy rain and heavy wind comes, and you will be having some the KSCB authority will cut the power to your home. That we call as this sustained interruption. അതായത് നിങ്ങളുടെ വീട്ടിൽ ഒരു മഴക്കാലത്ത് കറണ്ട് ഇൻറ്ററപ്ഷൻ ഉണ്ടാവുമല്ലോ, അതിന് നമ്മളെന്താ പറയുക, പിന്നെ ഒരു പാർട്ടിക്കുലർ ഒരു അരമണിക്കൂർ കൂടുമ്പോഴോ 1 മണിക്കൂർ വരെയോ, അതായത് 1 മിനിറ്റിനെക്കാട്ടും കൂടുതൽ ഉണ്ടാവുന്ന ആ വോൾട്ടേജ് ഇൻറ്ററപ്ഷൻ, അതായത് അതോറിറ്റീസ് വന്ന് ശരിയാക്കുന്നത് വരെ ഉണ്ടാവുന്ന ഇൻറ്ററപ്ഷൻ എന്ന് പറയാം സസ്റ്റൈൻഡ് ഇൻറ്ററപ്ഷൻ എന്ന് പറയും. So that is why it requires human intervention. So next we see the voltage imbalance. So this we see voltage imbalance in the upcoming classes. Okay, fine.